The so-called Astable Multivibrator is one of the most common circuits that you will find in electronics books 1960s, 1970s, 1980s and even now 2024. And well, I did quite a few experiments with that circuit, and there is one thing that I want to tell, and that is that this Astable Multivibrator sometimes or often does not want to start when the voltage to the circuit is, say, applied in a certain way. Say when the positive slowly goes up to a certain value, and in this case it is 12 volts, and here is, say, more or less the completely classical circuit of an Astable Multivibrator, and the issue is here the not starting problem. And I have already made another video on my YouTube channel where I have explained that a little bit, especially in that earlier video I was focusing on the base resistors, the base resistor of the second transistor and the base resistor of the first transistor. When they deviate a lot, it could be that when the voltage is applied, there is so much imbalance in the circuit that the circuit starts to oscillate. And the problem is that it does not always do that, and even on higher frequencies. Say, when you change here this 0.47 microfarad capacitor to 10 nanofarad, or here 10 nanofarad, could be that when the voltage slowly comes up to 12 volt, the whole circuit doesn't want to start, so it doesn't oscillate. Classical problem. In many books, in the theory, I seldom found, say, a kind of cure for that issue, but perhaps it had to do something with the supply voltage. Perhaps when the voltage is high, say in the order of 12 volt to 24 volt, 50 volts, the circuit in a certain way always wants to start. But my experience was that it did not always want to start, and that's why I published this circuit now. At first, a demo. The two capacitors that I've used here are electrolytics in the order of 1 microfarad, perhaps 2 microfarad or so anyway. Let's see what happens when we slowly add the voltage to this circuit without the relay, by the way. Anyway, let's see. Slowly add voltage now. 3 volt, 4 volt, 5 volts. Here 5 volts. 8 volts, 12 volts, 13, 14, 15, 16, 18 volts, 20 volts, and we don't see any, say, waveform on the oscilloscope screen. So that's a situation where this resistor is directly connected here without the relay functioning, and now I want to demonstrate how it works with the relay when that is functioning. Of course, that's logical. On a certain moment, the relay starts to work. Well, I have to do some adaptations. Yes. Well, this is that. So I've now connected the circuit in this way here with that relay here. And the good thing is that when the voltage gets to a voltage in the order of 12 volts, the relay is activated and suddenly connects the base. The bias is the first transistor, and that's what's happening. So in this case, because of the sudden reaction of the relay contacts, when that contacts close, it starts to oscillate. So there's a guarantee that it always starts to oscillate. So demo again. I slowly lift up the voltage now. 5 volt here, 6 volt, and on a certain moment now the LED lights up. That's completely logical, of course. But there is a certain moment where that relay closes and the circuit starts to work. So let me demo it again. The relay closes and now it works. It oscillates always. So this is a kind of cure for that problem. I mean, this is more or less, say, a kind of professional solution for that problem. And of course we have to do with a relay. Of course a relay is never a kind of ideal component in electronic circuits, but anyway, there are even, say, big television sets where you hear the click of that relay when the TV set switches on, for instance Samsung. Anyway, thus they also use that. Anyway, 3.8 volts now, and of course with such a relay we have to do with the voltage where it is activated and the, say, voltage where it is deactivated, and that differs. Has everything to do with, say, the magnetic properties inside the relay. Anyway, I think this is a good cure when you, say, want to make a simple multivibrator circuit, say to drive a high voltage coil or so, with capacitors not, of course, not in this range, but capacitors in the order of 10 nanofarad here and 10 nanofarad here, or even 4.7 nanofarad, 4.7 nanofarad. It could be that the circuit by itself starts to oscillate without that relay option. But on the other hand, I made an oscilloscope in the past where this circuit did not want to oscillate, and I had to find out. A kind of relay circuit to switch the multivibrator on. And that's what's happening here. Anyway, here's the waveform at the moment. Has of course everything to do and is in fact not related to the issue that I'm talking about. The waveform can be of any kind of way. Could be a much better square wave, could be another kind of square wave. Anyway, that's not the idea of this video. The idea is to make a kind of start circuit, to start a multivibrator to oscillate when a certain supply voltage is reached. Thanks for watching. the schematic again. And this is the activating relay. That suddenly gives that first transistor its bias, and that means that it starts to oscillate.